Okay. Write down homogeneous differential equation. Homogeneous differential equation. Homogeneous differential equation. Then a differential equation which is of the form dy upon dx equals f of xy upon g of xy, a differential equation which is of the form dy upon dx equals f of xy upon g of xy, where f of xy and g of xy are homogeneous functions where f of xy and g of xy are homogeneous functions of same degree is called a homogeneous differential equation. Okay, a differential equation which is of the form dy upon dx is equal to f of xy upon g of xy, where f of xy and g of xy are homogeneous functions of same degree is called a homogeneous differential equation. So first of all, we should know what is homogeneous function in two variables x and y, right? So write down what is a homogeneous function. A function of two variables f of xy is said to be a homogeneous function of degree n a function f of xy is said to be a homogeneous function of degree n if f of tx ty equals t to the power n f of xy. A function f of xy is said to be a homogeneous function of degree n if f of tx dy is equal to t to the power n f of xy. Okay. For example, f of xy is equal to x square minus 5xy plus of 2y square. F of xy is equal to x square minus 5xy plus 2y square. Now substitute x with 2x and y by 2y. So f of tx ty, f of tx ty equals tx whole square minus 5 into tx into ty plus 2 into 2y ty whole square. This is equal to t square x minus 5 t square xy plus 2 t square y square. Now we can take t square as common. This is equal to t square into x square minus 5xy plus of 2y square. This is equal to t square into f of xy. Right? So t to the power n f of xy. So the given function is a homogeneous function of degree 2 in two variables x and y. If the equation is of the form dy upon dx is equal to f of xy upon g of xy. If both are homogeneous function of same degree, then we can say that the differential equation is a homogeneous differential equation. Right? Then how to solve a homogeneous differential equation? Dy upon dx equals f of xy upon g of xy. Let both f of xy and g of xy are homogeneous functions of degree n. Suppose f of xy and g of xy are homogeneous functions of degree n. Then let f of xy and g of xy are homogeneous functions of degree n. Step 1, divide the right hand side, divide both numerator, NR means numerator, and DR means denominator of RHS, right hand side, by x to the power n. Then it will be a function of y by x. Step 2, substitute y by x is equal to b. Substitute y by x is equal to b, or y is equal to bx. Y by x is equal to b, or y is equal to bx. Differentiating both sides by x. So dy upon dx will be v plus x dv upon dx. Okay. So after the substitution, the equation will be reduced into variable separable form. The equation will be reduced into variable separable form. Okay. Let us come to solve a couple of questions. Solve dy upon dx is equal to homogeneous functions of same degree. Homogeneous degree, it is not homogeneous degree, homogeneous functions. Both f of xy and g of xy should be homogeneous functions of same degree. Okay. Both f of xy and g of xy are homogeneous function of same degree. Hello. 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 हाँ, Srijit बोलो. Hello. Srijit, are you getting my voice? Am I audible? Yes. So solve the equation dy upon dx equals x square plus y square upon 2xy. Here f of xy is equal to x square plus y square and g of xy is 2xy. F of xy is equal to x square plus y square and g of xy is equal to 2xy. Both are homogeneous functions of degree 2. Okay. Both are homogeneous functions of degree 2. To solve this equation, we have to divide both numerator and denominator of the right hand side by x square. So the equation will be dy upon dx is equal to x square plus y square upon x square divided by 2xy upon x square. This is equal to 1 plus y square upon x square all over 2 into y upon x. Right? Now substitute, let y by x is equal to b. Let y upon x is equal to b. This implies y is equal to b into x. On differentiating both sides by x, dy upon dx equals b plus x db upon dx. dy upon dx equals b plus x db upon dx. Now substitute dy upon dx is equal to b plus x db upon dx and y by x is equal to b in equation 1. Now the equation reduces to b plus x db upon dx, b plus x db upon dx equals 1 plus b square upon 2b. This implies x into db upon dx is equal to 1 plus b square upon 2b minus of b. This is equal to 1 plus b square minus 2b square upon 2b. This is equal to 1 minus b square upon 2b. So x db upon dx is equal to 1 minus b square upon 2b. Now the equation is in variable separable form. So we can solve this. This implies integral to b upon 1 minus b square into db is equal to integral dx. Integral to b upon 1 minus b square db is equal to integral dx. So if you substitute 1 minus b square is equal to z, 2b db will be minus dz. So 2b will be minus dz. Minus dz upon z is minus ln z. So minus ln 1 minus b square is equal to ln x plus, since both the functions are in the form of log, so we should add the arbitrary constant in terms of log ln c. So minus ln 1 minus, what is B? Y square by x square is equal to ln Cx. Okay, this is the answer. I hope it is clear to you. Did you understand, guys? Please write in the chat box. Is it clear? The previous slide, Shashwat. Okay. Previous slide. Done. Shashwat. Okay. Then write the question and answer. Then I'll go for next question. Quickly note it down. Okay. A similar type question. Act in JMN 2024. Write down the solution of the differential equation. The solution of the differential equation x square plus y square into dx minus 5xy into dy is equal to 0, where y1 is equal to 0. This is the initial value. That means when x is equal to 1, then y is equal to 0. I think you can solve this question. This is like the previous one. Try to solve it. Take 2 minutes of time and solve it. Otherwise, I will solve it for you. Solve it and send me the answer. SS Morban, Sarat Sahu, Saista Khanam, Realme. X square plus y square into dx minus 5xy into dy is equal to 0. Okay. The solution of the differential equation x square plus y square into dx minus 5xy into dy is equal to 0. Now solve it. X square plus y square into dx minus 5xy into dy is equal to 0. This implies dy upon dx is equal to x square plus y square upon 5xy. Now the right hand side, f of xy and g of xy are homogeneous functions of degree 2. Now divide both numerator and denominator of the right hand side by x square. So we'll get dy upon dx is equal to x square plus y square upon x square divided by 5xy upon x square. This is equal to 1 plus y upon x whole square upon 5 into y upon x. Let y upon x is equal to v. This implies y equals to vx, y equals to vx. So dy upon dx equals v plus x dv upon dx. Okay. Now substitute y is equal to vx and dy upon dx is equal to v plus x dv upon dx in equation 1. Now the equation reduces to v plus x dv upon dx equals 1 plus v square upon 5v. This implies x dv upon dx is equal to 1 plus v square upon 5v minus v. This is equal to 1 plus v square minus 5v square upon 5v. This is equal to 1 minus 4v square upon 5v. Now the equation is in variable separable form. So you can write this implies integral 5v upon 1 minus 4v square dv is equal to integral dx upon x. Clear? So derivative of 1 minus 4v square is equal to minus 8v. So we can write it as this implies minus 5 by 8. So 5 by minus 5 by 8 into minus 8v divided by 1 minus v square into dv equals dx upon x. Now substitute 1 minus v square is equal to 4v square. Sorry. Now substitute 1 minus 4v square is equal to t. Minus 8v dv will be dt by t is ln t. So minus 5 by 8 ln 1 minus 4v square is equal to ln x plus c. So boundary value, stop. So minus 5 by 8 ln 1 minus 4 y square upon x square is equal to ln x plus c. So y is equal to 0 when x is equal to 1. Y is equal to 0, x is equal to 1. If you substitute y is equal to 0, x is equal to 1, this will be 0. 1 minus 0 will be 1. Log 1 will be 0. Log 1 will be 0, implies c is equal to 0. So the answer, final answer is minus 5 by 8. Here I am writing the final answer. Minus 5 by 8 ln 1 minus 4 y square by x square is equal to ln x. Then you will simplify it according to the options given in the question. Right? Is it clear to you? Write in the chat box, is it clear? After a long time, MPC Baripada has joined. Quickly note it down. I'll write the next question. Is it clear? Please write in the chat. Is it clear? Nupur? Saswat? Is it clear? Okay, write down the next question. The solution curve of the differential equation the solution curve of the differential equation y into dx upon dy equals x into log x minus log y where x greater than 0, y greater than 0, and passing through the point e comma 1, and passing to the point e comma 1. This is the question. Sorry, log x minus log y plus of 1. Log x minus log y plus of 1. I hope you can solve this. If you understand the last two questions correctly, then you can solve this one. 2 minutes of time and solve it. Okay. So y into x dy, x upon dy, y into x dx upon dy is equal to x into log x minus log y, log of x by y plus of 1, right? So dx upon dy. This implies dx upon dy is equal to x by y into log x upon y plus of 1. Now substitute x by y is equal to v. X by y is equal to v. This implies x is equal to vy. This implies dx upon dy is equal to dx upon dy is equal to v plus y dv upon dy. V plus y dv upon dy. So v plus y dv upon dy is equal to v into log v plus 1. This is equal to v log v plus of v. This implies y into dv upon dy is equal to v log v plus b, and taking this b into right hand side, this will be minus b. Plus b minus b cancels. Now the differential equation is in variable separable form. Integral dv upon v log v, integral dv upon v log v equals integral dy upon y. Integral dv upon v log v equal to integral dy upon y. If you substitute log v as z, then 1 by v dv is equal to dz. dz by z is equal to log z. The log of log v is equal to log y plus c. Okay. Log of v is x by y is equal to log y plus c. The curve is passing through e comma 1. That means when x is equal to e, y is equal to 1. Substitute x is equal to e and y is equal to 1. So this is equal will be log of, to find the value of arbitrary constant c, substitute x is equal to e and y is equal to 1. It will be log of e upon 1 is equal to y is log 1 plus c. So log e is 1, log 1 is 0, log 1 is 0, so c is equal to 0. So log x by y is equal to log y. So log of x by y is equal to y. This implies x by y is equal to e raised to the power y. X is equal to y into e raised to the power y. Clear? बुझिपाल कि नहीं प्ले चार्ट बॉक्स रे लेख बुझी होछि कि साइस्ता कासत, is it clear? Then we will go for the next question. Write down the next question. The slope of the tangent of this tangent at any point xy slope of the tangent at any point xy on a curve y is equal to y of x. Slope of the tangent at any point xy on a curve y is equal to y by x is x square plus y square upon 2xy, where x greater than 0, if y of 2 is equal to 0, find y of 8. Find y of 8. This is the question. All of you know, if y is a function of x, then slope of the tangent to the curve y is equal to f of x at slope of the tangent at y is equal to f of x. अच्छा शाश्वत के वेट करिए कोई सब ये शाश्वत एनी प्रॉब्लम ओके शाश्वत सल्वित y is a function of x, then slope of the tangent at any point xy is given by dy upon dx, is given by dy upon dx. So it is given that dy upon dx equals x square plus y square upon 2xy. Already I have taught this question. You see, both the numerator and denominator are homogeneous functions of degree 2. Now we have to divide both the numerator and denominator of the right hand side by x square. The equation will be dy upon dx equals x square plus y square upon x square divided by 2xy upon x square. This is equal to now substitute y by x is equal to b. This implies y is equal to vx dy upon dx is equal to v plus x dv upon dx. Now the equation reduces to one minus v square upon 2b. So this implies integral to v upon 1 minus b square into db is equal to integral dx upon x. Derivative of 1 minus b square is minus 2b. If you substitute 1 minus b square as z, 2b db will be minus dz. Minus dz upon z is equal to minus ln z. So minus ln 1 minus b square. B is y by x. Y square upon x square is equal to ln x plus c. To find the value of the arbitrary constant, use the boundary value. Y of 2 is equal to 0. That means when x is equal to 2, y is equal to 0. If you take x is equal to 2 and y is equal to 0, x is equal to 2, y is equal to 0. Left hand side will be log 1. Log 1 is 0. And right hand side will be ln 2 plus c. That is ln 2 plus c, or c plus ln 2 is equal to 0. Implies c is equal to minus ln 2. So minus ln 2. So minus ln 1 minus y square upon x square is equal to ln x minus ln 2. So ln x by 2. So this implies ln 1 minus y square upon x square whole to the power minus 1 is equal to ln x by 2. So ln cancels 1 minus or 1 by 1 minus y square upon x square is equal to x by 2. Okay. We have to find out value of y when x is equal to 8. So x square upon x square minus y square. Writing here x square upon x square minus y square is equal to x by 2. X cancels. So x is equal to, so 2x is equal to x square minus y square. So y square is equal to x square minus 2x. Now put x is equal to 8. If you substitute x is equal to 8, it will be 64 minus 16 is equal to 48. So y will be root 48. Y is equal to root 48. So this is equal to 4 root 3. So value of y8 is 4 root 3. I hope it is clear to you. Ashwat, is it clear? Saista, write in the chat box. Next one happen? No, put it. Quickly note it down. जल्दी जल्दी लिख दो नेक्स्ट बार थ्योरी को इक्वेशन रिड्यूसिबल टू होमोजेनियस फॉर्म write down equations reducible to homogeneous form. Equations reducible to homogeneous form. Equations reducible to homogeneous form. The format of the equation is dy upon dx equals a1x plus b1y plus c1 upon a2x plus b2y plus c2. a1x plus b1y plus c1 upon a2x plus b2y plus c2, where a1 upon a2 equals b1 upon b2, where a1 upon a2 equals b1 upon b2. Sorry, a1 upon a2 is not equal to b1 upon b2. So by suitable substitution, this type of differential equation can be reduced into homogeneous differential equation. Okay. By suitable substitution, let substitute let small x is equal to capital X plus h and small y is equal to capital Y plus k. Small x is equal to capital X plus h, small y is equal to capital Y plus k. So dy upon dx equals d capital Y upon d capital X. Now substitute small x is equal to capital X plus h. So the equation reduces to dy upon dx equals a1 into capital X plus h plus b1 into capital Y plus k plus c1 upon a2 into capital X plus h plus b2 into capital Y plus k plus of c2. Right? So this implies dy upon dx is equal to a1x plus b1y plus c1 plus a1h plus b1k plus c1 upon a2 capital X plus b2 capital Y plus c2 plus of a2h plus b2k plus of c2. Clear? This equation will reduce, sorry. C1, C2 not here. Okay. This equation reduces to homogeneous form only when this expression is 0 and this expression is 0. If A1H plus B1K, if A1H plus B1K plus C1 is equal to 0 and A2H plus B2K plus C2 is equal to 0, then the equation reduces to homogeneous form. On solving this equation, these two equations simultaneously by cross multiplication, H is equal to B1 C2 minus B2 C1 upon A1 B2 minus A2 B1, K is equal to C1 A2 minus C2 A1 upon A1 B2 minus A2 B1. Okay. So now the equation reduces to D capital Y upon D capital X equals A1X plus B1Y upon A2X plus B2Y. Now divide both numerator and denominator of the right hand side by X. The equation reduces to A1 plus B1 into Y upon X by A2 plus B2 into Y upon X. Now substitute Y by X is equal to V. Now Y upon X is equal to V implies Y is equal to Vx. So dy upon dx is equal to V dV upon dx, V plus x dV upon dx. Then solve. Okay. This is the method how to convert a linear by linear expression, okay, into a homogeneous differential equation. dy upon dx is equal to linear by linear, and the lines are not parallel. Linear equation in two variables represents a two straight line. The lines are not parallel. When the lines are parallel, then the methods are different. Okay. Should we go for the question? Okay, write the solve. dy upon dx x minus y plus 1 upon x plus y, sorry, plus 2. Right? Now substitute is equal to capital X plus h, small y is equal to capital Y plus k. So dy upon dx is equal to d y upon d capital X. Now the equation reduces to d capital Y upon d capital X is equal to capital X plus h minus capital Y plus k plus 1 upon capital X plus h plus capital Y plus k plus 2. So after simplifying, capital X minus capital Y plus h minus k plus 1 upon capital X plus capital Y plus h plus k plus 2. This equation reduces to homogeneous form when h minus k plus 1 is equal to 0 and h plus k plus 2 is equal to 0. if you solve this equation, h will be minus 3 by 2 and k will be minus 1 by 2. So k will be 1 by 2. Okay. H is equal to minus 3 by 2, k is equal to 1 by 2, minus 1 by 2. Right? Now the equation reduces to d capital Y upon d capital X equals capital X minus capital Y upon capital X plus now divide both numerator and denominator by x. So dy upon dx is equal to 1 minus y upon x, 1 plus y upon x. Let y upon x is equal to v. This implies y is equal to vx dy upon dx is equal to v plus x dv upon dx. Thus v plus x dv upon dx is equal to 1 minus v upon 1 plus b. This implies x dv upon dx equals 1 minus b upon 1 plus b minus b. This implies x into dv upon dx is equal to 1 minus b minus b square upon 1 plus b. This is equal to 1 minus 2b minus b square upon 1 plus b. This now the equation is variable separable form. So integral 1 plus b upon 1 minus 2b minus b square is equal to integral dx upon capital X. जल्दी जल्दी लिखी दिया नेक्स्ट पेज यूज करबी तो इंटीग्रल 1 plus b upon 1 minus 2b minus b square dv is equal to integral dx upon x. If you substitute this one as t, then minus 2 into 1 plus b dv dt. So dt by t, dt by half dt by t integral dx upon x half ln t ln what is the 1 minus 2b minus b square is equal to ln x plus c. V is equal to y by x. So 1 by 2 ln 1 minus 2 into y by x minus y square upon x square is equal to ln x plus c. Okay. This is all about your homogeneous differential equation. जड़े पिला आज जड़े पिला कौन करेंगे पिला कौन करेंगे